We're going to look at probability with dice and cards. So these are going to go with a worksheet that I'm not able to replicate at the moment quickly. So just follow along with your worksheet if you have it. The first question, they want us to find the probability of rolling a difference of 3. So a difference of 3, we want our numbers to differ by 3. And this would be a thing, this chart would be a good thing for somebody to write down if you have time after you get a question figured out. Okay, so difference of 3, we'd have, for example, 1 and 4, 2 and 5, 3 and 6. We could also have 4 and 1, 5 and 2, 6 and 3. So that would be 6 options. On the chart here, 6 times 6, we have 36 total possibilities. So that's a 6 out of 36, or 1/6 chance of that happening. Number 2, they want us to find the probability of rolling factors of 6 on the first die. So factors of 6, first of all, are 1, 2, and 6, and 3. Not in that order necessarily. Almost forgot the 3. Anyway, so 1 on the first die would be these. 2 on the first die would be these. And then 3, and then 6. You could count them all up. There's 6 in each row, so that'd be 24 out of 36. Which you can reduce to 2/3. Remember, you can use the F to D button on your calculator to reduce PRB, second PRB. Another way you could do it is you could say it's 4 out of the 6 rows, so 4 out of 6 reduces to 2/3. On number 3, they want the probability of not rolling factors of 6 on the second die. So the factors of 6 again are 1, 2, 3, and 6. So basically we want the second die to be a 4 or a 5. So if the second die is a 4 or a 5, that would be these 2 columns, and that would be 2 out of the 6 columns, which would reduce to 1/3. Would be one way of doing that. Or you could have 12 out of 36 would also reduce to 1/3. This all these problems, by the way, we're assuming that we're rolling 2 dice, which they should probably tell us, but I guess the title says probability with a pair of dice, so I guess that gives it away. This one, they want the probability of not rolling a multiple of 5 on any of the die. Any of the dice, we could say. Okay, so multiples of 5, we're counting by 5. So that'd be like 5, 10, 15, 20. With these are 6-sided dice. So the only multiple of 5 that we could possibly get would be a 5. So the thing is, we want basically anything that doesn't have a 5 in it. So what you could do is start crossing out things that have 5s, which would be that row across and this row, or this column going down. So we crossed out, by doing that, well, we crossed out 6 things across and 6 down, but one of them, the 5, we did twice, so we can't count that twice. So we really didn't cross out 12 things, we crossed out 11 things. So we had 36, we crossed out 11, that means that's going to leave us 25. So 25 out of 36 chance of that happening. Just to mention, there is another option that you could do this. Basically, we want the probability of not getting a 5 and not getting a 5. Not getting a 5 on the first die, not getting a 5 on the second die. So the first die, So the chance of that happening, not getting a 5, there's 5 out of 6 other sides, so 5/6 chance that we don't get a 5 on the first one, and then a 5 out of 6 chance of not getting a 5 on the second one would be the 25 out of 36 chance. So especially if you don't have the chart made there, that would maybe make it easier. And a consideration, I mean, might even have to be like, you know, is there a way somehow you can make the chart and then you might have to like mark on it, but then erase it somehow. So maybe lightly marking on your chart so that you can reuse it again for another problem. Realistically, there'd probably only be 2 or 3 questions that would involve the dice anyway, but just something to think about. Number 5, they want the probability of rolling an even number on both die. So one way of doing this, again, we could just say what's the probability of an even and then an even. So we got a 50-50 chance of rolling an even. So 1/2 chance of getting an even on the first one, 1/2 on the second. Multiply would be 1/4. You could otherwise find them all on the chart and figure it out that way. It's going to take a little bit more time, but that could be done as well. Number 6, they want us to find the probability of not rolling a difference of 1. And one way to do that might be easier to look at what all do we have that is a difference of 1. So difference of 1, we've got 2 and 1, 3 and 2, 4 and 3, 5 and 4, 6 and 5, 5 and 6, 4 and 5, 3 and 4, 2 and 3, 1 and 2. So that's 10. So if there's 10 that have a difference of 1, that means the other one's 36 total. So that means the other 26 are not a difference of 1. So 26 out of 36, or 13/18 if we reduce that. Number 7, they want us to find the probability of rolling a difference of 4. Probably just as easy to find on the chart here. So difference of 4, we've got 1 and 5, 2 and 6, 5 and 1, 6 and 2.
And 1 and 5. Oh no, sorry. Yeah.
Okay, so that's 4 out of 36, which reduces to 1/9. Number 8, they want the probability of rolling a multiple of 5 on one of the die. So in other words, if we get a multiple of 5 on just one, so we want a 5, but we only want 1 5, basically, is how I'm taking it. So if you look at that, we've got 5, 6, 7, 8, 9, 10. Okay, and I guess if it has it, this would be the question mark about what do we do about the double 5, but their answer is just saying if we have it on at least one of the die, so that's 11 out of 36 is how they've got that one. That's not the best wording on that question. Number 9, they want us to find the probability of rolling factors of 5 on both dice. So factors of 5 would be 1 and 5. So we want 1 and 5, either a 1 or a 5 on both dice. So that'd be like a 1 and 1, 5 and 1, 1 and 5, 5 and 5. So that'd be a 4 out of 36, which is 1/9 chance. And our last question on the probability with dice, they want us to find the probability of not rolling a sum of 7. Sum of 7 is the most common sum that we can have. and it actually goes across the diagonal. So depending how you write this. So that would be the different options that have a sum of 7. There are 6 of them. So it's basically the complement of that, which would be 30. It's the other ones. So 30 out of 36, which reduces to 5/6. So this actually was just the probability with a pair of dice. Cards we will get into at another point. Have a good day.